Hello world, I made this channel to guide you to become a good physicist and help you to become a good problem solver regardless of your background and age. If and only if you're willing to put in the effort. I try to keep things as simple as I can and provide you with as much information as I can. First, I'll try to build a good mathematical foundation for you, and after that, or whilst doing so, I'll start teaching physics, from the most elementary concepts to the master's degree level of a graduate physicist in the first half of 21st century. So in these first few lessons, I'll go through the mathematical foundations we need before we start with the physics. So for the first lesson, I'll start with power laws. So why do we need to use powers? We use powers to write mathematical expressions more compactly, which in turn makes them more readable and easier to understand. They are widely used across maths and physics, so we need to understand them in order to understand the more advanced subject. So let's define what a power is. Imagine we have an expression like this: 2 times 2 times 2 times 2 times 2 times 2. It is very cumbersome to write it like that, especially if you want to repeat it over and over again. So instead of writing it like this, we write it like that. So we just count the number of times that this number is being repeated. We write this number, which is 2, at the bottom, and we count the number of times that it is being repeated on the top right hand corner of it. So 1, 2, 3, 4, 5, 6. You just write 6 at the right top right hand corner of number 2. So imagine if someone asks you what 7 to the power of 3 is. It's very easy. You just write 7 3 times. 7 times 7 times 7. And 7 to the power of 3 is equal to 7 times 7 times 7. That's it. Very easy. So, one more thing to know. The number that we write at the bottom is called the base, and the number at the top is called the exponent. So, in order to calculate the powers, we need to first expand it either on paper or in our heads and just multiply. So if someone asked you what 4 to the power of 3 was, we just write it as 4 times 4 times 4. I put the brackets here in order to say I'm going to multiply this first. So 4 times 4 is 16 times 4, and that will be 4 to the power 4 times 10 is 40. 4 times 6 is 24. 24 plus 40 is 64. So 4 to the power of 3 is just 64. So what about 5 to the power of 2? That will be just 25. What about 5 to the power of 3? That's just 25 times 5. And I'm just going to use calculator here, and that's going to be 125. What about 5 to the power of 4? That's 6 to 5. 5 to the 5, just this times 5, and that will be 3125. What about 5 to the power of 6? That's just going to be 15625. So as you can see, the first two digits in where 5 is the base, we have 2 and 5 being repeated all the time. So you have 25 on the last two digits. And for the third digits, yeah, it just repeats 1 and 6. 1 and 6. I'm pretty sure the next one, the third digit of 5 to the power of 7 is going to be 125. So I'm like something, and in fact it is 78125. So you see, you just can predict whatever with those rules what each digits, certain digits of powers of 5 are. So I encourage you to do more of these to see if you can find more patterns and maybe create a video about it. I really want to see it. So let's generalize what we have learned so far. In general, we can write any power like this: a to the power of b, where a and b can be any number that you can think of, like positive, negative, minus 0.5, 1.3, or whatever that you can think of. There are some special names for some powers, and that is when we have a number to the power of 2. If we had n, that will be n squared. If we had pi, that would be 2 pi squared. If we had 2, that will be 2 squared. We can either say 2 to the power of 2, pi to the power of 2, n to the power of 2, or we just can say n squared. So I just wanted to introduce their namings. Also, if we have any number to the power of 3, we can just say, instead of saying n to the power of 3, we can say n cubed, 5 cubed, or 6.5. So lastly, let me explain what the difference between a to the power of n to the power of m and a to the power of n to the power of m is. So imagine someone wants to test your mathematical skill, and they'll ask you a question like this: what is 5 to the power of 2 to the power of 3 and 5 to the power of 2 to the power of 3 are? In the first question, what they're actually trying to say with these parentheses is that what is 5 to the power of 2 to the power of 3 is. So whenever you see the parentheses, you calculate whatever inside the parentheses are. So here it's just going to be 25 to the power of 3, and that is equal to 15625. And for the second question, what they're trying to say is that what is 5 to the power of 2 to the power of 3. So first you need to calculate whatever is outside. So you need to work your way from the outer circles to the inner circles. So here it's just going to be 5 to the power of 8 and 5 to the power of 8 is just 3,9,0,6,2,5. Here was to use a little mathematical knowledge, which is known as orders of operations. So let me explain it in a very informal way. So whenever you have a mathematical expression, it will either have parentheses, multiplication or division, or addition and or subtraction. So whenever you have a mathematical expression that contains all these, first you need to calculate the parentheses. Whatever it is inside the parentheses, you need to calculate them first. If you have multiple parentheses, first calculate the most inner parentheses, and next the next inner parentheses next, and so on until you get to the last part. And if you had inside these parentheses a multiplication or subtraction, addition or subtraction, do the multiplication and division first. Powers also are in this category, includes powers. So whenever you have powers, multiplication and addition, you have to do them first before addition and subtraction. So that was the first part of power laws. I hope you learned something. Thank you for watching.